if you have headphones or cell phones, those need to go away now. Thank you. Waiting for a couple phones. Beauty. Okay. So yesterday we did multiplication. Today we're going to do division of our rational expression. So when we think rational, we want to think fraction. So that's what we're working with. Expressions, they have x's and numbers, and we are going to simplify them. That's kind of our goal, right? We want to simplify the expression. So remember, when we divide fractions, when I'm dividing one fraction by another fraction, the general rule when we're working with all fractions, what do I do? When I'm dividing one fraction by another fraction. How do I do that? Zion? Yes, so we're going to take the flip of the second fraction and we'll change the division to multiplication. Okay, so if I have something like x, oh, I'm on an eraser. If I have something like x over y times, I don't know, or divided by, sorry, z over q, my job is to take that second fraction, only the second one, first one stays as it is, and we flip and we change to multiplication. Okay, I do not need to change any signs of anything or anything like that, other than, of course, I change the sign of the division to multiplication, but I'm not switching anything from negative to positive or anything like that. Okay, so simply take the second fraction, flip and multiply. Okay? Right, yep. This doesn't want to work for me. There we go. Sorry for the weird rating. Flip and multiply second fraction. Okay, so division and multiplication are pretty closely linked then, right? Because every single time I see a division, I'm going to just flip and multiply that second fraction, and then we'll do the multiplication steps as usual. So if we're kind of getting the hang of multiplication, that's good. There's only actually a couple extra things that we have to do when we have division, but mostly we'll just kind of follow some of the steps that we did yesterday once we do the first few initial steps. Okay? So I don't know why this got spaced out here, but the general thing that I'm going to kind of follow here is factor or common factor everything that I possibly can. Okay, so sometimes factoring means common factoring. Okay, all numerators, all denominators, if they're not already factored for us, we will restrict. Okay, so this is before I do any flipping or multiplying. And then I will flip and multiply, and I will restrict again. Okay, so anything that was once in a denominator needs to be restricted. Okay, so because I actually flip and then I have a new denominator, I have to restrict that new denominator that I get. So essentially, when I'm dividing, I'm going to restrict this, I'm going to restrict this, and then this will also end up being restricted because I flip it. So the only thing when I'm dividing that doesn't get restricted is the top of the first fraction. Okay? So you could technically kind of skip the second restrict if you remember that that has to be restricted. But in general, we want to kind of follow this. And then we can start canceling. Okay? So this one is already pre-factored for us. So step one is a check. When we go to restrict this one, our initial restrictions that we can see in the denominator are -2 and +2. Okay? So we would have those. And then, so that's my first restrict step. My second thing, or my third thing that I would want to do is flip and multiply. So I'm flipping the second fraction only. And then you guys see how now we have another denominator that needs to be restricted there? So that is the second time we restrict. So we say, okay, x can also not be -7 now that we have that in the denominator. Okay, and then again, sometimes I just like bracket those guys up just so we know not to cancel any piece of that. Has to be a group. Oops. Okay, and then last part is simplify. Okay, so these are my restrictions. And now I can start canceling things. So what can I cancel here? The x minus 2's. Anything else? That's actually it. So I'm going to maintain those brackets on the second part of the numerator here, just because it's actually 2x times both of these things. It's 2x times the x and also the 2. Whether you put the brackets on the x plus 7 on the bottom, you can drop those, right? Because it's just x plus 7 left down there. It's not being multiplied by anything or anything like that. So if you'd like, you can just drop those brackets. Are we done? No? Yes? I heard a no. Yeah? Yeah, we're done. That's all we can do. Yeah. So we want to be mindful. Okay, so the other thing that we want to be mindful of is, like, although this 2x has a multiplication between it, if I went to cross it out with the bottom x, that bottom x still has a plus beside it, right? So I don't want to cancel those guys. So yeah, just be mindful about that. And also the other thing that we just want to remember is that I have to be canceling a top with a bottom. So sometimes people cancel like two denominators. We can't do that. Okay, so just be careful about that too. Good, questions? I saw a hand somewhere. Did I? No, okay. Okay, so we will actually have some more practice with multiplication today because of the nature of division questions. So we're just going to kind of follow those 5 key things that we want to do. So first things first, we want to factor everything. Don't flip and multiply first because I want to see all the possible restrictions. So first things first, multiply, not multiply, factor. I've got a difference of squares down here. So that's going to factor into x plus 7, x minus 7. Okay. Two things that multiply to 14 and add to 9. 7 and 2, good. Okay. Restrictions before I do anything at all. -7, 7, and -2. Very nice. Yeah, you can do that if you want. Plus minus 7, that works. Okay, flip and multiply. Only the second fraction gets flipped. And then we're going to want to check if there's anything we need to add to our list. So have I created any new restrictions in the denominator now? Is there anything that needs to be added now that we have this new denominator here? Or do we have everything we need in the list? Yeah, so this time we actually just so happen to have everything that we need already. That won't always happen though. Okay, now we can cancel. So we're looking for things, so remember we must cancel a bottom with a top. So I think we can cancel the x plus 2's. So is that a bottom with a top?
Sorry, no.
Okay, so is there anything else then? There's actually nothing else that we can cancel. So that might happen sometimes where you can cancel maybe one thing. So what I would like to write this as is, because it's an x plus 7 times another x plus 7, what's the way that I can condense that? Elise? Yeah, x plus 7 times itself, right? X plus 7 squared. Okay, and then I still have the x minus 7 as well.
And it's no longer one, it's no longer, so we don't have a numerator? Is that why we wrote it like that?
The numerator over here is, we're just left with a 1 there. Yeah.
Okay.
So it's like 3x times 1.
Okay.
And then, of course, we remember that our restrictions were also part of our answer. So if you want to rewrite them with your final. But make sure you have them somewhere boxed up as part of your final answer there. So that's kind of, both parts of that are our answer. Any questions for this one? Okay. Try another one. Okay. Do you guys want to try this one? Okay, you try it, and I'll start putting up the steps in a couple minutes. Okay, so first step, factor and common factor everything. And then you're going to kind of start your list of restrictions there. Okay. No, you can have it slanting left or slanting right. It shouldn't matter. Okay, so my initial restrictions are done. Alex, question? The brackets on the bottom? So we're factoring trinomial when a equals 1 here. So for the one on the left, I'm looking for two things that multiply to negative 10 and add to negative 3. So the numbers were negative 5 and 2. And then same deal over here. It multiplies to positive 20 and adds to negative 9. And the numbers were negative 5 and negative 4. Okay? All right. So we're going to flip and multiply.
Can you take anything out of 4x squared? Like if you divide it by 2x, or is that like not allowed?
It's a single term, yeah. So we don't actually ever common factor single terms. We only do common factoring if we have more than one term. So you'd have to have like terms being added or subtracted. Yeah, good question. Sorry, this keeps ruining my rating. Okay, any new restrictions that we need to add to our list once we've done this?
Yes.
Yes. What do we need to add? We need to add 0 to the list because of this 4 times x squared. So we're actually just going to add that up to our list there. And that should be everything. Okay, so that anything that is in a denominator at any time needs to be restricted. Okay? What did you guys go ahead and start canceling from here? Carla?
X minus 5.
X minus 5, lovely. The whole group. What else? Luca. Do we cancel x minus 4s? They're both on top, right? So it must be a top with a bottom. Okay?
No, because canceling out.
Elise?
Let's do 2x and 4x first.
Okay. So I can reduce the 2 and the 4 to 1 and 2. And also, the x's, right? So we'll do it in black. We'll do 1x from the top with one of the x's from the bottom. So I'll be left with 1x there when I cancel out 1 from each.
Wait, why would you be left with 2x from the bottom?
Oh, I'm left with 2x, but I'm not left with like x squared, right? So out of those 2 x's that I have there in the squared part, I'm only left with x. Okay. Anything else? Are we good? Okay, I think we're done canceling, so let's just condense here. What did you guys write for the numerator part? Yeah, it's x minus 4 times x minus 4, so x minus 4 squared. And then usually we would write this as like the 2x in front and then times x plus 2.
So just collecting and gathering the like terms
Yeah, so I'm just multiplying the numerators and I'm multiplying the denominators. That's what we do when we multiply fractions, right? Just get used to writing it like this. It's not wrong. It's like 7 times 1 or 1 times 7, but usually we would write it with the kind of like coefficient and single x out front. But not a huge deal if it's in the opposite order. Okay, and then we have all of those restrictions from above as well as part of our final answer. So you don't have to rewrite it, but just make sure it's boxed somewhere. Cool? Okay. Restricting along the way is helpful because we won't miss anything. But if you happen to do it at the end, you need to look back and see everything that was once in a denominator. Questions? We good? Okay. Last one. Let's try this. So factor, common factor, everything. I think this one can only be common factored. And remember, we can't really do much with single terms. Single terms have to just stay as they are. Initial restrictions here. 0 is the only initial restriction that we have, actually. Yeah, that's right. So it's not -3. Why is it not -3? Yeah, like 3 times -3 doesn't give us 0, right? It gives us -9. So 3 times 0 gives us a denominator of 0. Same thing over here. 0 squared is 0, and then times 20, that's 0, right? Okay, now we can do our flip and multiply. You could. I just try to tell people to wait to cancel, because if you start canceling, then they might miss a restriction. But if you feel like you can make sure that you have all of them and start canceling right away, that's fine. One thing that we definitely don't want to do is start cross-canceling when we have a division between. Carla?
So when you common factor a plus 3 from 2a and then 10a,
Yeah.
you're just dividing out because you can only take a from each, right? So it's just a plus 2.
Yeah.
That's what you left over.
Yep. So I took out an a from each, and then on the right side I took out 5 from each. So then I was left with 2 with that 10. Okay. Do we need to add anything to our restrictions list?
-2.
Yeah. Okay, we need to make sure we restrict that new denominator there. Okay, good. So we can cancel a full a plus 2 with another full a plus 2 here. Those ones are fun. A and A. $20 and $5, yeah, that would be 4 and 1. Anything else? Okay, so 1A out from each, right? Okay, so I'll take out 1 here and 1 here, and I'm left with an A. Good. Okay, so we're left with 4A over 3. And then we have our restrictions here. Box those up too. Good. Questions on this guy? Okay, so as you're doing your worksheet, we just want to look out for those trinomial factoring when a is not equal to 1. So there's one in number 12 that has to be long factored. So just make sure you keep an eye out for those guys. And the other thing that we want to keep an eye out for is just making sure that we restrict anything that was ever once in a denominator. Okay? All right, so we're doing the back of yesterday's worksheet.